So we're right in the middle of this massive shift in how we build autonomous AI coding agents, and honestly, it's about time. We're finally moving away from just obsessing over the models themselves and looking at the much bigger picture. Today, we're drawing from an incredible deep dive by engineering leader Adi Osmani into this concept called agent harness engineering. We're going to break down why the secret to a truly great coding AI isn't just the brain you drop into it, but the scaffolding you build entirely around it.
Look, we've all been there, right? You're watching an AI get completely lost in some 40-step task, or worse, it confidently pushes a broken update that just nukes your entire afternoon. When that happens, it is so tempting to just blame the model. We tell ourselves, well, the AI just isn't smart enough yet, guess I'll just wait for GPT-6. But the material we're looking at today argues that this mindset, it's fundamentally flawed.
And that brings us to the missing half of the equation, which is a concept coined by Viv Trivedi. He points out that a raw model is not an agent. The model is literally just one input. Everything else, the prompts, the tools, the memory policies, sandboxes, feedback loops, that whole shebang is the harness. And here's the kicker. A decent model with a great harness is going to beat a great model with a bad harness every single time.
Here is our roadmap for today. We'll quickly cover the missing half, dissect the anatomy of a harness, look at the ratchet principle, figure out how to battle context rot, and then explore this new frontier of harness as a service.
All right, kicking things off with Section 1, the missing half. It's not just about the model.
So when an AI fails, we really need to stop throwing our hands up and calling it a model issue. As the team at HumanLayer frames it, it's actually a configuration problem. You don't just sit around waiting for a smarter AI to drop, you fix the harness. If your agent runs a destructive command or completely ignores your coding conventions, that failure is highly legible. You just add a rule to your agents.md file, or you update a hook to block that specific action in the future.
To see the power of this configuration in action, just look at Viv Trivedi's team. They were testing Claude Opus 4.6 on a coding benchmark called Terminal Bench 2.0. Now, they didn't touch the model at all. They just gave it better tools and sharper constraints for their specific codebase. And that exact same agent jumped 25 spots on the leaderboard. It literally moved all the way from the top 30 into the top 5. The model was identical. The entire gap in capability was just a harness gap.
Okay, let's move right into Section 2, Anatomy of a Harness, Opening the Hood.
At the very core of the harness, you have this engine. It's the classic React or Ralph loop. The model reasons about a problem, it uses a tool to take action, observes the result, and then repeats. Now, a really great harness provides the ultimate general-purpose tool for this loop, which is Bash. Instead of trying to pre-build some hyper-specific tool for every single action imaginable, you just give the agent a command line and let it build what it needs on the fly to autonomously solve problems.
But obviously, a loop needs a place to operate. Without a file system, you're essentially just copy-pasting code into a chat window, and let's be real, that is not a real workflow. The file system is your foundational primitive. It gives the agent a durable workspace so it can read docs, offload intermediate work, and actually carry knowledge over. Add Git on top of that, now your agent can instantly track its progress, branch out for experiments, and easily roll back its own mistakes.
Because honestly, you definitely do not want an AI going rogue and running unverified code directly on your personal machine. That's where sandboxes come in. They provide a safe, completely isolated, and scalable environment for the agent to use its tools. And a good sandbox comes fully loaded with pre-installed defaults, things like test CLIs, language runtimes, headless browsers. This is absolutely crucial because it lets the agent observe its own work, take screenshots, and actually verify if the code it wrote functions properly.
Finally, we have the enforcement layer, hooks. These are scripts that run at specific lifecycle points, like right before a file edit or a commit. This is the barrier that separates you hoping the agent remembers an instruction from the system physically forcing it to comply. Hooks are exactly how you prevent an AI from confidently nuking a production database or force a linting check so it doesn't waste precious tokens arguing with itself over whitespace formatting.
Which brings us to Section 3, the ratchet principle. Every mistake is a rule.
So, in harness engineering, there's this concept of the ratchet. Basically, every single mistake the agent makes is treated as a permanent signal. It's not a funny one-off story. It's not a bad run where you just hit retry. If the agent ships a pull request with a commented out test, you don't just sigh and fix it manually. You tighten the ratchet. You update your agents.md rulebook to say never comment out tests, and then you add a pre-commit hook that literally searches for skipped tests. You engineer the system so the agent can physically never make that exact mistake again.
This whole design philosophy is best summed up like this. Success is silent, failures are verbose. Think about it. If a type check passes, the agent hears absolutely nothing. It just keeps working. But if it fails, the harness catches that failure and injects the error text right back into the agent's loop. That makes the feedback cycle incredibly fast, super cheap in the common case, and directly actionable for self-correction when things inevitably go sideways.
All right, moving on to Section 4, battling context rot, keeping memory sharp. Look, if you drop a 2,000-line log file straight into the context window, you are going to absolutely tank the agent's performance. To survive, a top-tier harness has to constantly curate what the model is actually looking at. It uses compaction to summarize older context. It uses tool call offloading to only shore the very head and tail of massive log files. And it uses progressive disclosure, meaning it hides complex tools until the exact moment the task actually requires them. Context is incredibly scarce, and your harness is the delivery mechanism to protect it.
But, according to Anthropic's engineering team, sometimes for those really long horizon jobs, compaction just isn't enough to cut it. You have to use full context resets. The harness will literally tear the entire session down and rebuild it from scratch using a highly structured, compact handoff file. It completely wipes out all the conversational noise, which honestly is pretty much exactly how we hand off work or onboard a human engineer to a new project anyway.
And that leads us to our final stop, Section 5, Harness as a Service, the new frontier.
If you look at the top coding agents out on the market today, side by side, we're talking tools like Claude Code, Cursor, Aider. They actually look way more like each other than their underlying models do. Even if the brains inside are totally different, the industry is rapidly converging on these exact harness patterns because they are the load-bearing pieces of scaffolding that actually turn a generative AI into a system that ships real software. And this convergence is giving rise to Harness as a Service, or HaaS. We're moving away from just pinging raw LLM APIs, and instead we're building on top of Harness APIs. You no longer have to rebuild memory policies, sandboxes, or orchestration loops completely from scratch. HaaS lets you start at version 0.1 right out of the box, so you can spend your valuable time just tuning the domain-specific rules and hooks for your own unique codebase. So as these models keep getting better and better, imagine a near future where harnesses aren't just statically pre-configured at startup. What happens when they start acting like compilers? When they can dynamically assemble the perfect tools, spin up custom sub-agents, and pull in the exact context just in time for every single unique task. It's a future where your AI isn't just chatting with you anymore. It's compiling the perfect environment to solve your absolute hardest problems. Definitely something to think about as we build the next generation of agents.